Lesson 2.7. Use absolute value functions and transformations. An absolute value function is a function with the absolute value. The general form is f of x equals a times the absolute value of x minus h plus k. The simplest version is when a is 1 and h and k are 0, so it's just y equals the absolute value of x. That's the graph. Notice the point in the center of the graph is called the vertex. The graph looks like a V because when the x values are negative, the y values would be positive. So the entire graph is positive. The right side, the graph is like y equals x, so the slope is 1. The slope of the left side is negative 1. Transformations change the graph size, shape, position, or orientation. We're going to deal with a few transformations today. The first is a stretch or shrink, and this will be vertically. A is the factor of the graph that's stretched or shrunk. So when A is 2, it'll be twice as tall. If A was a half, it'll be half as tall. That means we multiply the y coordinates by A. Since the slope of the right side of our absolute value graph was 1, the new slope will be A. That's only for absolute value functions. Another transformation is reflection, which flips the graph over a line. If the a is negative, the graph will be flipped over the x-axis. Another transformation is a translation, which moves the graph. H is how far the graph moves to the right. K is how far the graph moves up. Since the vertex of the graph, the simplest one, y equals absolute value of x, was 0, 0, the new vertex will be over h and up k, or h, comma, k. And in general, you apply the stretch, shrinks, and reflections, so anything's the a, before the translations. Because order of operations says multiply before adding. So let's graph and compare with y equals the absolute value of x. So here's our function. And if we compare it to the general form, we can see that the h is 2 and the k is 3. Because it's x minus h, we have x minus 2. It's plus k, we have plus 3. So that means the vertex is 2, 3. We're translated 2 to the right and 3 up. The a is 1. That means the slope of the right side is still 1. It has no stretch or shrink, so the slope stays 1. So the slope of the right side will be 1. So overall, comparing with y equals the absolute value of x, it's translated 2 to the right and 3 up. So there's my vertex, which is at 2, 3. And the slope of the right side is 1. So I went up 1 over 1. And that gives me my line. Let's try another one. Y equals 1/4 the absolute value of x. If we compare with the general form, we can see that h and k are both 0. They're not there, so when you subtract or add, and it doesn't do anything, then they're 0. So it's not translated, the vertex is still 0, 0. The a, however, is 1/4. That means it's 1/4 as high, so it looks like it's squashed down. And the slope of the right-hand side will be 1/4. So the slope of the right side is 1/4, so overall our graph is shrunk vertically by a factor of 1/4. So my vertex says 0, 0, and my slope of the right side is 1/4 to get my other points. And that's what the graph looks like. Notice it's squashed down. Here's another one. Again, if we compare it with the general form, we can see a couple things. First of all, in the general form, it's x minus h. What we have is x plus 1. So that's the same thing as having, but we need that as a minus. So it's the same as having x minus a -1. That makes h -1, and the k, because -2 is the same thing as plus a -2, k is -2. So it's translated 1 to the left and 2 down. The new vertex will be -1, -2. The a is also -3, so the slope of the right side is -3. Since it's negative, that means it's reflected over the x-axis and is upside down. The 3 for the a means it's stretched by a factor of 3, so it'll look like it's stretched out. And the h and the k mean it was translated 1 left and 2 down. So my vertex is at -1, -2. Follow my slope of -3, so that's down 3 and over 1. And we get our graph. Alright, now let's go the other way. Here's the graph. What's the equation? So we need to know the vertex. Vertex is right here at -3, 5. So h is -3 and k is 5. We also need to know a. The slope of the right side is down 5 and over 1. So the rise is -5, the run is 1. -5 divided by 1 is -5. So our slope, our a, is -5. We know it's negative because it's opening downwards. So now, to fill that into our general form, we know a, h, and k. Remember that minus a negative, because h was -3, becomes plus. Alright, now let's try some general transformations. So here is some function. It is not an absolute value function, it's just some random function. And we want to graph -1/2 of that function. The negative means it will be reflected over the x-axis. The 1/2 means that it's half as tall. So when I go to graph this, I need to reflect it over the x-axis. So it's reflected directly over the x-axis. So this point was 1 above, so now we're 1 below. This point was 2 above, now we're 2 below. This point was 4 below the x-axis, so this point's 4 above the x-axis. Then do the 1/2. So make everything 1/2 the distance from the x-axis. This point here was at -1, so now we're at -1/2. This point was at -2, so now we're at -1. This point was at -4, so now we're at -2. So this is our final graph. Let's try another. This time, got an H and a K. Remember, it was x minus h, so h is +1, and k is 3. So we've translated 1 to the right and 3 up. So move every point 1 to the right and 3 up. Take a point, 1 to the right and 3 up. Take a point, go 1 to the right and 3 up. Go 1 to the right and 3 up. And that's all for today. Here's your assignment.